Hello, back again. I hope you are well. Okay, so what I'm going to do here is I'm going to try out a couple more complicated problems that we weren't able to get to last time, maybe with some more steps in them. One more, and then I'm going to write down some problems for you to try. So here's one, for instance, 3 times 2 to the x plus 1. And let's say plus 6 is equal to 9. So check this out. Here's the exponential part here, 2 to the x plus 1. It's got a coefficient of 3 in front, which is multiplying, and we're adding 6. So this one, what we want to get at is we want to isolate the exponential part before we logarithm. Okay, we just can't log both sides yet. We've got to clear the plus 6 out, and we've got to clear the multiplication by 3 out, right? So what we're looking at in effect might look something like this. 3 times u plus 6 is equal to 9. We're isolating the u part. First we're going to subtract the 6, then we're going to divide by 3, right? Okay, so we're going to subtract 6, and that's going to give us, so now we've got 2 to the x plus 1, right? And we subtract 6 from both sides, right? And we get equals to 3, right? So over here, by comparison, we now have 3u is equal to 3. Now we divide both sides by 3. So here we're going to divide both sides by 3, right? And that's going to give us 2x plus 1 is equal to 3 divided by 3 is 1. Okay? So now, we didn't have to do that in the previous examples, but we had to do that here because we always want to isolate this exponential part. Now what we do is we log both sides. So now we log here, log 2 to the x plus 1 is equal to log 1, right? And this is going to be, so now the x plus 1 comes to the outside, so this is x plus 1 times log 2. Remember, this whole exponential part motors to the outside and becomes the coefficient. And over here, this is whatever log 1 is. So now, if you go back, by the way, you might recognize what log 1 is equal to at this point, but we're going to leave it as it is, right? And we're going to now divide both sides. Now that we've got this, we're going to divide both sides by log 2, right? And so we've got x plus 1 is equal to log 1 divided by log 2. Now, that's not, let's be clear, log of 1/2, right? The logs don't combine that way, okay? Subtraction on the outside, like log 1 minus log 2, that would give us log 1/2 on the inside, but we can't, those don't combine like that, okay? So anyway, log 1, by the way, if you do log 1 on your calculator, that's equal to 0, as it happens. So now we've got x plus 1 is equal to 0 divided by log 2, which is equal to 0. It's equal to 0 there, because 0 divided by any number is going to be 0. Subtract x is equal to -1. Okay? All right, so, by the way, let's check our answer there. We put -1 back up here at the top. It's a nice even number. Should be easy to do that. 3 times 2 to the -1 plus 1 plus 6 supposedly is 9. Well, -1 plus +1 is 0. So that's 3 times 2 to the 0 is equal to 9. 2 to the 0 is 1. That's 3 times 1. 3 times 1 is 3, plus 6, Oh yeah, that's equal to 9. So that all works out great. So it's easier to see, you know, when the answers come out to be nice even numbers, that this operation or working here really does work. Okay, so there's a more complicated one, and you can run back and look at that again. Plus also, these are all going to be, I'm going to put these up in printed notes too at some point this afternoon. Okay? All right, pretty soon. Okay, so I would love you to try these examples. Okay, so I'm going to write them out right here. Try these. Okay, and I'm going to put up, and I'm going to put these up in a class worksheet for you to try out if you want to. These are just going to be some of them. Okay, so let's see. So number 1, 6 to the 3r is equal to 36. Try that one out. That one you might notice, 36, here's a tip, 36 can be written as a power of 6. So that one's got a shortcut because we can write these as a common base. Okay, number 2, how about 13 to the b power is equal to 28? And how about 12 to the x power is equal to 46. Try that one out. This is number 3. Okay, so number 4. 7 to the p minus 5 is equal to 5. Try number 5 here. You can do 7 to the negative 6r, that's supposed to be an r there, equals to 98. Okay? So try that one out. So try those 4. I'll put down a couple more here. Number 5. How about 9 times 10 to the 6x minus 4 is equal to 53. And then number 6 is going to be 2 to the 2 times 14 to the 2 minus 5x minus 4 is equal to 22. So spend some time trying those out, okay? And then I will come back with the answers. So you should put the video on pause right now. I will come back with the answers in a little bit, okay? Or rather, I'm gonna do it right now, but you're not gonna watch it. You're gonna have your video on pause. Log both sides. So on this one, log both sides. The b swings out in front. B times log 13 is equal to log 28. Divide both sides now by whatever log 13 is. All right. B is equal to whatever log 28 is divided by log 13. And according to Mr. Calculator, log 28 divided by log 13 is 1.299. Okay, this guy here, we're going to log both sides. All right. X swings out front. So I've got x log 12 is equal to log 46. Divide both sides by log 12, right? X is equal to log 46 divided by log 12. Okay, log 46 divided by log 12. Why, that's about 1.541. It's okay with me if you leave them in log form, just like that. You don't have to do the rest on the calculator. This guy here, we log both sides. Right, p minus 5 swings out front. It's all one number. Right? So p minus 5, dividing both sides now by log 7, is equal to whatever log 5 divided by log 7 is. And now, on this one, you could divide those out, but I'm not going to bother. I'm just going to add 5 to both sides. And my final answer, written as your book might say in exact form, p is equal to whatever log 5 divided by log 7 is, plus 5. So these are, let me circle them here, these are answers. I'm only doing the decimal ones to show you that this is, it's a real thing that we're doing here, okay? So here we log both sides, log 7, negative 6n, log 98, okay? Negative 6n comes out to the front. Oh, it's 6r. It's supposed to be an r, sorry. It's supposed to be an r. Okay, 6r is equal to log 98. Log, so it's going to be negative 6r, sorry, times log 7 is equal to log 98. That's a misstep right there. Negative 6r just came out in front. Divide by log 7. So this is 6r is equal to log 98 divided by log 7. Now here we divide both sides by negative 6, and that becomes, I'm going to write one big expression here, which is extremely awkward. But you can go ahead and evaluate this on the calculator. You do the top division first, and then divide by negative 6. Otherwise, you can definitely leave it just like that. Okay, now 5 and 6 are going to be more room, so I'm going to put those on another sheet. Okay, rewind, come back to those if you need to. Let me put this over here. Okay, so number 5 looked like this. 9 times 10 to the 6x minus 4, right, was equal to 53. That was the original problem. Now, remember, now we've got a coefficient in front, and we've got to isolate the radical part, or rather the exponent part first. We just can't log both sides. It makes it more complicated that way. So I'm going to divide both sides, and you know what, just for yucks, well, no, never mind. So we're going to do 53 divided by 9, and that is, I'm going to round this off. It's 10 6x minus 4, that's, well, 53 over 9. And I'm going to leave it like that. Now that doesn't come out evenly, so I'm going to leave that as a fraction. It's okay if we do it that way. Now it just makes our answer look more complicated at the end. Now we log both sides, right? 10 6x minus 4 log 53 over 9, right? So now the exponent swings out front. Right? That's one clump. Divide. So 6x minus 4 is equal to log 53 over 9, whatever that is, divided by log 10. And now here, we just add 4 and divide by 6, right? So that's 6x is equal to log 53 over 9 divided by log 10 plus 4. So we just added 4. Now we divide the whole shebang by 6. X is equal to log 53 over 9 log 10 plus 4, and then this whole thing is a 6 on the bottom. Now, I know that's very awkward looking, but that's the way we will write the exact answer. Okay, so that's enough. Okay, I'm going to post the answers to number 6 as part of the notes this afternoon. Hopefully this is enough to get on with. I'm going to have a third video here in which we're going to solve equations with logarithms in them. But